Welcome at the University of Tübingen. I'm Peter Großöme, Senior HPC Engineer at Macware and responsible for the installation of the new Top 500 cluster system BinAC at the University of Tübingen, which has a theoretical LinPack peak performance close to 550 teraflops. The system consists of 304 nodes in total. We have 240 compute nodes with a new Intel Broadwell CPU and furthermore 60 dual socket GPU compute nodes with 2 NVIDIA Tesla K80 in each of these dual socket GPU servers. And finally we have 4 systems with Intel Haswell quad socket CPUs inside, and these nodes are all connected via Mellanox FDR and InfiniBand and have global access to the 720 terabyte BGFS parallel file system. The storage subsystem has a throughput of 16 gigabytes read and write performance per second.
Ich bin der Leiter des Universitätsrechenzentrums in Tübingen, das den schönen Namen Zentrum für Datenverarbeitung trägt. Ich möchte auch der Firma Macware ganz herzlich danken, ganz besonders danken, sodass die Firma Macware tatsächlich erst am 25.04. den rechtsverbindlichen Zuschlag bekommen hat und dann so schnell war mit Bereitstellung und Installation, dass wir schon Anfang Juni die Benchmarks für die Top 500 Liste fahren konnten. Das ist eine Riesenleistung. Den Herrn Heidelmüller, den Herrn Großöme möchte ganz herzlich persönlich danken, dass das möglich war, und freue mich da über die bisherige und auch die künftige Zusammenarbeit mit Ihnen. Es hat sich sehr bewährt an der Stelle.
So the BinAC cluster was designed especially for applications from the bioinformatics. The design process was done with a tight integration of scientists from this area to meet the specific demands from these researchers. The applications that will run on these clusters belong to the fields of molecular dynamics, high throughput sequencing, high throughput image analysis, and simulations as well. We have a lot of GPUs in these clusters for the molecular dynamic simulations, but also for researchers from the field of deep learning, where we see an increasing demand of these kind of hardware architectures. Compute nodes are especially designed for sequence analysis. We have 128 gigabytes of RAM in the nodes, which is very beneficial for sequence analysis, which is necessary for sequence analysis. So we can really do high throughput sequence analysis on these machines. So we are dealing with a lot of temporary scratch data produced by these sequencers, produced by the high throughput imaging facilities that have to be stored on a scratch storage for the computation, on very fast scratch storage for the computation.
The BinAC cluster was also designed for the astrophysics departments in the county of Baden-Württemberg. The requirements from molecular dynamics is also a requirement for a research area in the astrophysics, the development of planetary systems. This is from a mathematical point of view very similar to molecular dynamics, but in a very different size, from moleculars to planets and to suns. For this research, the GPUs are very important since they are able to simulate the behavior and the time development of particles, of many particles, millions of particles, which we can't do on classical CPU systems. Besides that, we also have interest in large MPI jobs. So the network layout is such that we have non-blocking InfiniBand islands of a size approximately 900 cores. And this is very good for some of our astrophysics applications where we need a lot of cores for MPI applications.
Be proud of the new top 500 cluster system that we get in a very short time frame into the top 500 list. Thank you for the offer and thank you for the collaboration to the team of the University of Tübingen.